Now, let's move on to the next stress, decreasing temperature. So, at this point, temperature is being lowered. Okay, we may put it in the freezer or put it in cold water, temperature is being lowered. So how does it affect the equilibrium? So let's look at the equation here. In this equation, we're going to focus on this term, the heat. When we decrease temperature, or when we have a change in temperature, we are adjusting the amount of heat inside the container or in the substance. So if we decrease the temperature for the equilibrium reaction, it means that we are removing heat from the reaction. So what we could do is to treat this heat, this term, like a product. In this case, since this is exothermic reaction, and we can use the logic of what happens if this is being removed. Well, if the heat is being removed, then it is not an equilibrium. And to get back to equilibrium, we have to produce more heat to go back to equilibrium. So there will be more reactions shifting this way to make more heat, so that it can get back to equilibrium as soon as possible. And this is the reason why we put the arrow going to the right, because it's going to shift right to make more heat, to produce more heat, and having the equilibrium reaction go back to equilibrium. Okay? Now, if it is an endothermic reaction, then the heat would not be on the product side, it will be on the reactant side. And you would treat the heat just like the reactant, just like what we did here. Okay? So you understand what is being removed or what is being added. If you have increasing temperature, it means heat is being added into the system, and then you consider which way would it shift to go back to equilibrium. Now, number 5, addition of argon gas. So these are all gases, and now one extra gas goes into the container. What's going to happen? Well, if you think about what we just mentioned in number 3, is that the more gas molecules you have or particles you have, the more pressure it will be. Okay? So if you put in more argon gas and inert gas, well, this gas would not have any reaction with this in the system. It's just an inert gas, a noble gas. So it doesn't participate in the reaction, but it will increase the pressure. It will increase the pressure of the container. So will this affect the equilibrium? Well, let's look at it very closely. Yes, having an extra gas introduced into the container would increase the total pressure. But if you look at the number of the gas molecules, the partial pressure of these two substances would remain the same. Because the number of moles of these two molecules remain the same, then it should have the same amount of the partial pressure. And because of this reason, there will be no shift. There will be no shift in this reaction, because the concentration of these gases remain the same. It is in the same container, same number of gas molecules. So introduction of introducing an extra gas, which is inert gas, no reaction with these two chemicals, will not affect the equilibrium process. So here's a recap of what we've learned so far. For the Chatelier principle, we have to understand what happened in a given time frame. And you have to use logic to understand what has been done to the system, and how does the system respond to go back to the equilibrium state. So make sure you understand this timeline. At the very beginning, it is at equilibrium. And after some time, some stress is being done onto the equilibrium reaction, the system. And the system will eventually go back to equilibrium. And what Le Chatelier principles allow us to do is to understand what happened in this time frame. And this is the reason why we draw these arrows up and left and right, okay? And you may be asked to find out how does the concentration change when you have this particular shifts of the reaction. Now, if you understand the shift of these directions of the reactions, it should not be difficult to understand the change of the concentration of these chemicals. So let's just say that if it shifts to the left, what happened to the concentration of NO2? Well, if more reactions going this way, that means we have more NO2 being produced. Then the concentration of the NO2 is going to go up. So the major thing that you have to understand is the direction of the shift in the equilibrium process. So hopefully you understand the logic, and if you still don't understand, I would suggest you to look at this tutorial again, and so you would have a better concept of the Chatelier principle.